Hello, everyone. It's my pleasure to welcome everyone of us to a very short video on technical and scale efficiency of egg producers in Nigeria. And the method can be applied to technical and scale efficiency of whatever enterprise in any location. So I would like to use Poultry folder as my working directory. So let me set the working directory, set working directory, choose my directory. So my directory is Poultry folder. So having set my working directory, the next is to import my data sets. So let's click on file here. So we have, I want to use egg real. This comma separated version. So egg.csv here. We have, so let's import the data set. Import. So here we have the data set. Let's return to our script file. Let's look at few description of the data set. In order to have the names of the variables, column names, let's run these names agree. So here are the various variables. We have zone, state, sector, household ID. Yeah. Egg produce per week, egg produce, a number of layers, and so on and so forth. Let's try to do some kind of data manipulation description. So we would need this package, dplyr, as well as table 1. Let us look at the distribution by zone and states of the respondents, because we actually, the data is extracted from general household survey with 4. So let's run this. Okay, so this is copying these results to Excel, but in CSV format. So we can get these results. This is the results, table 1. So take us to table 1. So this is the result, distribution of spreading by state and zone. This is how the results looks like: state, zone, frequency, percentage. So let's go back to our R. Let's look at the distribution by poultry production system. Using FAO standard, we try to classify the production system into 3. We have backyard, where the size is not more than 100 chicken or layers, and semi-intensive, where the size ranges between 101 and 2000. Then anything above 2000 is classified as intensive. So Then let's get the frequency distribution by size. So this is what we're trying to do here. Run. No, it says size not found. Okay. So this, I think I need to run it from here. Good. So let's run this. And this is needed in order to export the data sets to Excel. And we can see the results in table 2. So let's go to table 2. Table 2. So this is it. So we can see that the data set is filled with backyard production system. So very close to 99%. So just very, very few belongs to semi-intensive and intensive production system. So let's proceed. So let's get the summary statistics of the quantitative variables by the production system. So in that wise, we want to use ASNA package. So this ASNA. So we try to run it. So let's run it. So let's look at it. Yes, table by is the function. Size. That is, we want to obtain all these, the summary of these variables by size. That's what it means. So let's run it. See. Yeah, I think we can see the variables clearly here. We have egg stored, cost of basin, cost of veterinary service, cost of water, cost of feed, cost of labor. So, and this is exporting the results to Word documents. So we can see the table we can see the result in table 3. So let's look at table 3 here. So this is how the results will be. This is summary statistics of an output and input variables by production system. So here we are looking at backyard, intensive, and semi-intensive. Then the value of egg sold. So, and if you look at the p-value from the ANOVA test of differences in the mean, you can see it's highly significant. So the same apply to cost of vaccine, cost of base service, and a lot more. So let's proceed. And that takes us to computation of the technical and scale efficiencies. So in this case, we want to use farrell package. So let's run it here. Okay, beautiful. So browse in order to get the data set. Don't forget we are using the grid. Open. So model tuning. So X sales is our dependent variable. So for independent variable, we have the layers. Then we have those are the laying eggs among the layers. So we have vaccine costs, cost of vet service, cost of water, cost of feed, labor, others. So the identification column is our DMU. That's the household ID. So calculate the efficiency. So let's click on this scale efficiency. So we wait a little bit for the results to come out. So the result will soon come out. So beautiful. So here we have the results. We can download it here. It's going to be downloaded as CSV formats. So this is the result. So we click on this. So this is the results. So here you have the constant return to scale, variable return to scale. This is the scale efficiency. Then you have the decreasing return to scale. So these are different scales. Optimal return to scale, then decreasing and increasing return to scale. So that is interesting. So let's what we can do now, you sort this in ascending order, so smallest to largest. Ensure that the selection is expanded, expand the selection, so sort. Then you will copy everything here. Copy. So and merge it with the air grill data. If you have done that, you will obtain this. This is how I obtain this air grill tool. You can see. So this is it. I hope it's clear. But don't forget that before you do that, you need to sort this ID here too, so that you're going to, so you are merging the IDs. You are merging by the ID, so you sort this also. So that's interesting. So that is it. So which means we'll continue to work with air grade 2. So we come here. So now we have data with all the efficiencies, technical efficiency, constant return to scale, technical efficiency, available return to scale, scale efficiency, and a lot more. Then the various scales. So the first thing we quickly want to do is to obtain the return to scale by states. So in that wise, we need table 1. Sorry, we need to close this. So table 1. Good. So let's run this. So this is the results here for various scales for various states. So we can see the results in table 4. So this is the results. Let's go to table 4. So this is the results here. So let's go back to R. So the next thing we want to do is to obtain the efficiency levels by various states. So we go by states, and we get the average for constant return, variable return for scale efficiency. So let's run this. And this is exporting the results to Excel. So you can see the results in table 5. So let's come here, see the results. So this is the results. This the T and SC for various states. So we can obtain the same for various production systems. And that is what we have tried to do here. So again, we export the results to look, all these things they are just one. It's warning message, no error. So don't bother yourself about that. So then write your results. So table 6. Sometimes we may want to look at the result here before you. So just type size here. So you can see the result already there. So that's it. So table, and the result is presented in table 6. Then the last one is by sector. Sector means whether the poultry farm is located in urban area or rural area in the country. So that is what we've tried to do here. So this is exporting it to Excel, but you may quickly check for this. You can look at the results here actually. URBF. So these are just the results for different efficiency levels, scale and technical efficiency for various states, various sectors, and by poultry production system in the country. And like I said, the method can be used for any enterprise. Thank you for joining me until we meet again. So I think now I will stop sharing. So try to use your own data sets in order to practice. Thank you.